We're swimming in data these days, right? But on its own, it's just a bunch of numbers. The real magic, the good stuff, happens when you figure out how to ask the right questions, how to find those hidden patterns, and tell the stories that are just locked away inside. And today, we're going to talk about the key that unlocks all of it: SQL. Okay, so let's jump right in with a real-world example, because honestly, it's so easy to get tripped up by data if you just look at the surface. Raw numbers can paint a picture that isn't just a little off, it can be completely wrong. So let me ask you a question. Let's say we're looking at property crime data for some big US cities. If you're just looking at the raw numbers, the total number of crimes, which city would you guess has the biggest problem? Let's take a look. And yeah, at first glance, the answer seems pretty obvious, doesn't it? I mean, look at that. New York City has almost 130,000 property crimes. It just blows the others out of the water. San Francisco's not even close. So, case closed, right? New York's got the biggest problem. Well, not so fast. And this is where things get really interesting. When we add just one piece of context, population, and we calculate the crime rate per 1,000 people, the whole story just flips on its head. Suddenly, Tucson, Arizona is at the top of the list, and New York, it's way, way down at the bottom. Its rate is 4 times lower than Tucson's. This is the key takeaway, folks. The raw number told one story, but adding context told the real one. So that begs the question, right? How do we get to that true story? How do we ask the data for that all-important context? Well, we need a way to talk directly to the databases where all this information is stored. We've got to learn its language. Okay, first up, where does all this data actually live? It's stored in something with a bit of a mouthful of a name, a Relational Database Management System, RDBMS for short. The easiest way to think about it is like a huge, super organized digital library. All the information is filed away perfectly in tables. And all the big systems you've probably heard of, MySQL, Oracle, SQL Server, they're all types of RDBMS. And the language we use to talk to that library, that's SQL. It stands for Structured Query Language. It's basically the universal language for all these databases. It's how we ask them to do things. Store stuff, change stuff, or, and this is the big one for us, go find and bring back the exact piece of data we're looking for. Now, I know structured query language sounds kind of formal and intimidating, but don't let it fool you. At its core, SQL is really just a way to have a conversation. Seriously, you ask a question, the database gives you an answer. It's just a back and forth between you and your data. All right, so just like any language, SQL has some basic grammar. But the good news is its core structure is actually super simple and logical. It's all built around one main idea: tables. Pretty much everything in these databases is organized into tables, which look a whole lot like a spreadsheet. You've got your vertical parts, those are the columns. Each one is a specific category, like first name or city. Then you have the horizontal parts, the rows. Each row is one complete record, all the info for one specific person or thing. Okay, so SQL commands basically come in 2 main flavors. First, there's DDL, or Data Definition Language. This is all about the structure. It's how you create a new table or alter an existing one. Think of it like building the bookshelf. Then you've got DML, Data Manipulation Language. This is for the actual data inside the tables. It's how you select information, insert new records, or update old ones. This is like putting the books on the shelf you just built. And here it is, probably the most fundamental phrase in all of SQL. It's like the hello, how are you of data. Select star from my table. So select just means show me. The little star, the asterisk, is just a shortcut for all the columns. And from tells it which table to look in. That's it. It's the simplest way to just say, hey, database, show me everything you've got in this table. Okay, so we've got the basic grammar down. Now let's get to the fun part. Let's see the incredible storytelling power of SQL when we start putting those words together to ask much more interesting questions. This right here is where SQL becomes a superpower. You're not staring at some massive, overwhelming spreadsheet anymore. Instead, you have this precision tool that can sift through millions, even billions, of rows of data to pull out the one specific insight you need and package it up into a clear, simple story. For instance, with just one SQL query, you can take a mountain of US Census data and do more than just list populations. You can tell it to calculate the percentage change over 10 years. And what you get back is a story about how the country is shifting. I mean, look at this. Kendall County, Illinois, and Pinal County, Arizona. They more than doubled their populations in just a decade. That's a huge story that was just hiding in the raw numbers. And it goes way beyond just that. SQL is like a Swiss Army knife for data. You can use it to do all sorts of calculations, sure, but you can also use it to clean up messy data. Like, you know how zip codes sometimes lose their leading zeros? SQL can fix that. Or, and this is really cool, you can join completely separate sets of data together to uncover relationships you would have never, ever seen otherwise. And you know, sometimes when you're exploring data with SQL, you stumble onto some really weird, surprising stuff. So check this out. If you're looking at the longitudes of US counties, they should all be negative, right? Because we're in the Western Hemisphere. But then you might find this one strange outlier, the Aleutians West Census Area in Alaska. It has a positive longitude. So you think, is that a mistake, a typo? But no, it's because those islands stretch so far west that they actually cross the 180-degree meridian and pop out into the Eastern Hemisphere. How cool is that? I love how the author, Anthony DeBarros, puts it. He says, it's a fact you can tuck away for your next trivia team competition. And that really gets at the heart of it. You know, data exploration is a process of discovery. And sometimes you just find these little gems that are just plain cool. So, we've seen how data can trick you at first glance, and how SQL is the language that lets us dig deeper to find the real story. And that brings us to the most important part of all of this. Here's the thing. Learning SQL isn't really about becoming a programmer. It's about becoming a better detective. It's a tool for curiosity. It's for anyone out there who wants to get past all the noise and opinions and find answers that are actually backed up by real, verifiable evidence from the data itself. Because in the end, the power isn't really in SQL itself. The power is in the questions that it lets you ask. The data is literally everywhere, holding on to countless stories about, well, everything. They're all just sitting there, waiting for someone to come along and ask the right question. So what questions will you ask?